Yeah, in our last class, we have seen about the SR latch, right? The set, reset, latch, right? As I said earlier, the set, reset, latch has one problem at whenever both set and reset as high, right? When both your reset and set inputs are high, the state of your output is called as undefined, right? So you cannot define of you will have q and q bar equals 1, right? So which is called as not defined, or maybe that input should not happen, right? To overcome that problem, we uh, we can make a small change, and we can make a JK flip flop, right? So JK flip flop. Oh, sorry. So JK latch, right? I would write it as JK latch. Right, there is a difference between flip-flop and latch, as we have seen in our last class, right? If a latch with a clock input, then that is a flip-flop, right? So there is a a kind of a small difference between the latches and flip-flop, right? For example, now and consider SR flip-flop, right? So this will be your set and reset inputs, right? So set and reset inputs. This is your Q and this is your Q bar. As I said, right? If I draw the truth table of the SR latch or an right? So I could say SR Q bar, right? So this could be 0 0, right? 0 1 1 0 and 1 1, right? 0 0 means, yeah, Q bar is actually not going to change, right? So this state or no change, right? If your reset is 1, Q is 0 regardless of your previous one. If your set is 1, Q is 1 regardless of your previous one. And then this state is not defined, right? Or invalid, right? You could use either not defined or invalid, right? So that is not going to, that it means in your circuit you should maintain that 1 1 is not going to happen, right? Let's see how we can make a JK flip-flop, or how we can overcome that 1 1 problem in a JK latch, right? Not a flip-flop, right? So this is an SR latch, right? So what I'm going to do is I'm going to have an AND gate, right? Two AND gates. Let me have two AND gates, right? And then you can have J and then K, which are my inputs, J and K, right? And then I will feed back J with Q bar, right? I could mark it as, right here I have my electrical contact, right? And then K into Q. K into Q. Right. So now let's see how this works, right? Since it is an SR flip-flop or an SR latch, right, and this is an AND gate, right? So AND gate means, yeah, if I draw the truth table of an AND gates, A, B, Y, right? So 0 0 0 1 1 0 1 1, right? So your y will be a dot b, right? So 0 0 0 1. Clear? 0 0 0 1, right? So don't worry about these things, and let's start from that 1 1 thing, right? So if j equals 1 and k equals 1, right? J equals 1 and k equals 1, and assume that your q equals maybe 0, right? So your q is 0, right? Before this stage, your q equals 0, right? So j equals 1, k equals 1, q equals 0 means, yeah, that 0 will be fed back to your AND gate. And if it is 1 0, so your reset output becomes 1, right? So 1, sorry, reset becomes 0, right? If reset is 0, okay, now if k is 1, right? K is 1, and at the same time, let's see that your q bar is 1, because if q is 0, then q bar should be equal to 1 in a previous step, right? So what you can do is, yeah, that 1 will be fed back to this one, and then 1 1 becomes 1. Clear? Remember, when you are giving 1 1 to a JK flip-flop to an active SR flip-flop, remember this is not at 1 1 condition, right? So the SR flip-flop is not at its 1 1 stage, right? So it becomes set equals 1 and reset equals 0, right? If set equals 1 and reset equals 0, then your Q was 0 at the initial condition, and that becomes 1, and immediately your Q bar becomes 0. Clear? Q bar becomes 0. Now, okay, again, so you are keeping j into 1, k into 1, but the Q is changed into 1, sorry, 0 to 1, and Q bar have changed from 1 to 0, right? Now, okay, so Q bar is 0 means, of course, that is fed back to here, and that becomes 0, but J becomes, or J is kept as 1, right? So 1 0 becomes, now for the next step, set is turned into 0, right? At the same time, Q becomes 1, and that is stored as 1, right? So 1 and 1, so your reset turns into 1. Clear, right? So whenever to the next step, right, now your set becomes 0 and reset becomes 1, which means whatever the output is, just reset it, right? So if Q is 0, that becomes 0, and hence your Q bar becomes 1, right? So, and this operation will keep on continuing, right? This operation will keep on continuing, right? Okay, so if I would say that when your j and k equals 1, right? So your output is actually toggling or free running, right? We can discuss about the difference between free running and runaway, or toggling, right? So now we can use it as toggling, right? So in an SR flip-flop, if we use an additional feedback, right, that becomes JK flip-flop, right? JK flip-flop, and now your truth table is changed into 0 1 1 0 1 1, of course, right? So they are, right, your uh, 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 K is actually equivalent to R and J is equivalent to S, right? Based on the figure here, right? So this is Q and Q bar, right? When both are 0, this is no change, right? When K is 1, your reset is 1, so Q becomes 0, and when J is 1, that is set, so your Q becomes 1, hence it becomes 1 and 0. Q bar becomes 1 and 0. And in an SR flip-flop, that 1 1 becomes invalid. Here 1 1 becomes toggle. Toggle means 1 becomes 0 and 0 becomes 1, right? If we write down the excitation, the state table, right, with J, K, Q, N with Q, N plus 1, right? J, K, Q, N plus, so let first J is 0, Q is 0, and yeah, this is 0 and 1, right? So the next will be 0, 1. Let Q, N is 0 and 1. Next is 1, 0. Q is 0, 1. Finally, 1, 1. 0 and 1. Right now, let's see how it changes, right? So when 0, 0, as I said, it is no change, right? So 0 becomes 0, 1 becomes 1. There are no change in the state. So Qn plus 1 will be equal to Qn. At the same time, right, whenever K is 1, as I said earlier, K is equivalent to your reset. So when your reset is 1, whatever or regardless of your previous state, your present state becomes 0. Right? On the other hand, yeah, at the same time, when J is 1 and K is 0, which is equivalent to S is 1 and reset is 0. So regardless of your previous state, your next state becomes 1. And right, this is the last and interesting step. So whenever 1 1 happens, as I said, yeah, your flip-flop, your latch is going to toggle. I would say when it is 0, your Qn plus 1 is 1, right? So if it is 0, Qn plus 1 is 1, and if your Qn is 1, Qn plus 1 is 0. Here, this is the only difference between JK and SR flip-flop, right? So at SR flip-flops, 1 1 is actually invalid, and in JK flip-flop, 1 1 is toggle, right? Right, now let's see about the difference between flip-flops and latches, right? A flip-flop and latches of this is actually a JK latch, right? This is not a JK flip-flop, and this is a JK latch, and this is a SR latch, right? I would say I can draw the JK latch as something like this, right? So JK, right? So I have two inputs, and then I have Q bar, right? Two outputs, right? These are called as latches, right? As we seen earlier, so whenever accidentally if you introduce a 1 or 0 at your J or K terminals, your output is going to change, right? Your output is completely depends on any changes, right? So we should prevent your latches from these small accidental changes, right? For that, we introduce another line called clock, right? We can make it a CLKO clock, right? For an SR flip-flop or a JK flip-flop, we can introduce a line called clock, right? Clock is actually will give you signal, something like this, right? A clock signal is actually kind of a square wave pulse train, right? Square wave pulse train, right? So yeah, yeah, so we can say that a full pulse is actually from going here to coming down and then up to this one, right? So if I draw a simple pulse, right, in a big shape, right? So let me draw something like this, right? So as I draw that, right, this should be rapid, right? But it cannot be rapid, right? There will be a small time delay, right? So I would say for ideally they should be perpendicularly going up and then coming down, but practically that is not possible. There will be a small delay, right? Now I would say that, yeah, from here to here the time is actually, yeah, capital T, right? Right, and then, yeah, these two are called levels, right? This one is actually positive level 1 and this is level 0, right? And these are called as edges. This one and this one are called as edges, right? So this is called as positive edge and this is called as negative edge, right? This is called as positive edge and this one is called as negative edge, right? A flip-flop can be triggered by either the level of the edge, right? So if it is a level triggering flip-flop, the clock line will be simply a line, right? Clock line will be simply a line. If it is an edge triggering flip-flop, right, you will have a small triangular sign, something like this in the clock, right? So if it is just a line, it is a level triggering flip-flop, right? I would say it as a flip-flop. After the clock line is introduced, the latch turns into a flip-flop, right? So if it is a triangle, then that is a edge triggering flip-flop, right? If it's just a triangle, that is called as a positive edge triggering flip-flop. If you have a circle outside along with that triangle, that is called as negative edge triggering flip-flop, right? In a positive edge triggering flip-flop, the change in state will occur only during the positive edge, right? In a negative edge triggering flip-flop, the change will only occur at the negative edge, right? In level triggering flip-flops, yeah, the change can be occurred anywhere in the level, right? There is a huge difference between, or a huge advantage on edge triggering flip-flop over level triggering flip-flop, because the time taken for the edge triggering is much lower than the levels, right? So this will go very fast, right? As I said, there will be a small time, but that is rapid, but that will remain at high and low state for pretty long time, right? For a comparatively long time, right? So whenever, if it is an edge triggering flip-flop, right? For example, if it is an a level triggering JK flip-flop, right? So the flip-flop will trigger along these long time interval T by 2, right? Let this be T by 2, right? So if it is T, this will be T by 2. So during that T by 2, the output is going to change based on your input. For example, now assume that you are giving 1 and 1 to the JK flip-flop, which is a edge triggering flip-flop, right? I'll draw the diagram something, right? The diagram will be, yeah, this will be a clock, which is a level triggering JK flip-flop, and you will have CLK, this is J, and this is K, this is Q, and Q bar. Assume that the clock is working much slower, right? And your flip-flop operates very faster. right? So when J equals 1, K equals 1, and if it is a level triggering flip-flop, right, this high is going to remain for a long time in the clock, right? So during that time, yeah, if Q is 0, it is going to become 1, and then if it is still remain 1, that will become 0. And right, if it is still 1, yeah, that will become 1. Right, so here, if you have your clock signal something like this, right, if it is slower, so your Q will be something like this, right? Will be keep on oscillating. Right, so this is called as a free running condition or runaway condition, right? But this disadvantage can be overcome if you are using a level triggering flip-flop, right? Sorry, an edge triggering flip-flop, right? Which means your flip-flop will operate whenever the positive or a positive edge is occurring in the clock, right? So yeah, that's all about JK flip-flop and JK latches and about your clocking, right? So if it is a level triggering flip-flop, yeah, the change will happen only at this point, right? So it will keep on continuing, right? So whenever, right, I would say this is your next one. Yeah, if J and K is 1, so right, if it is an edge triggering flip-flop, right, so it will be changing from, if it is 0, it will be changed from 1, and then it will be kept constant until it receives the next positive pulse. And whenever that next pulse is received, yeah, your previous stage is 1, right, and then that will be toggled to 0. Right, so this will be used a lot in your counters, right? So this application, right, or the changing states during the edges can be used in your counters, right? So yeah, that's all about JK flip-flops, and we can see about counters in our next class.